This is the example video for substitution. So let's take a look at the first problem. Y equals 7x plus 11 and y also equals 2x plus 6. So to solve a problem like this, we have two equations where the y is all by itself. That's good news. That's good for us. So our main goal when solving a problem using substitution is to get one variable by itself. In this case, we have two. So for this system, since we'll only have one solution, an ordered pair with x and y, we know that y equals 7x plus 11, and it also equals 2x plus 6. So to solve this problem, I'll take this 2x plus 6 right here. And since I know y equals this, I will plug this in for a y in the top equation. Okay, so just replacing this y or substituting it with 2x plus 6. So when I do that, I have 2x plus 6. Okay, this used to be y in the first equation, now it's 2x plus 6, equals 7x plus 11. And now I just solve for x. So I will subtract 7x from both sides. When I do that, 7x minus 7x cancels. 2x minus 7x will be negative 5x. And then I've got the plus 6 equals 11. Now I'll subtract 6 from both sides. When I do that, 6 minus 6 cancels. So I have negative 5x equals 11 minus 6, which is 5. So I can divide both sides by negative 5. When I do that, negative 5's cancel over here. So I'm left with x equals 5 divided by negative 5, which is negative 1. So now I can take this negative 1, and since I know x is negative 1, I can plug this negative 1 in for x in either the top equation or the bottom equation. Doesn't matter, you will get the same answer, or you should get the same answer, and solve for y. So how about I pick this bottom equation here, and I'll replace the x with negative 1. So y equals 2. Instead of x, I have negative 1 plus 6. So 2 times negative 1 is negative 2. Then I haven't touched the plus 6, so I'll add it to the back end. So negative 2 plus 6 is going to be positive 4. So I've solved for x, I've solved for y. I would like your answers in this format. Negative 1, comma 4. So this is an ordered pair that tells us that these two lines, when graphed, cross at the point negative 1, 4. Pause the video if you need more time. Okay, same type of example here. So just because I moved this my bottom expression up to the top equation last time, how about I take this top expression and I move it to the bottom one. So I'll take this and I'll plug it in for y right here, because my original system here tells me that y equals 6x plus 7, and it also equals negative 4x minus 13. So I get 6x plus 7 equals negative 4x minus 13. So I just replace my y in the second equation with this 6x plus 7, because I know y equals that as well. So now it's just a matter of solving for x. So I will add 4x to both sides. When I do that, negative 4x plus 4x cancels. 6x plus 4x is 10x. And I have plus 7, which I haven't touched yet, and this negative 13, which I have yet to touch. So now to solve this, I'll subtract 7 from both sides. When I do that, 7 minus 7 cancels. So I have 10x equals negative 13 divided by, or negative 13 minus 7, which is negative 20. So now to solve, I will divide both sides by 10 to get the x by itself. 10 divided by 10 will cancel out. So I have x equals negative 20 divided by 10, which is negative 2. So now we can take this negative 2 and plug it in for x in either the top equation or the bottom equation and solve for y. So let's do the top equation this time. So we have y equals 6. Instead of x, I'm plugging in negative 2 plus 7. 6 times negative 2 is negative 12. And negative 12 plus 7 is going to be negative 5. So these two lines cross at the point negative 2, negative 5. All right, moving on to number 3. Pause the video if you need more time. Okay, so this one's a little bit different. So we have y equals 5x plus 8, which is a line in slope-intercept form. And we have 5x minus y equals negative 8, which is a line in standard form. Okay, so remember, as I said for problem 1, our goal for substitution is to get one variable isolated, meaning completely alone. So I have that here. Taking a look at my top equation, this y is all by itself. So what I'll do, because I know y equals 5x plus 8, I'll take this 5x plus 8 and I'll plug it in for y in the bottom equation. Okay, so if I rewrite everything, I have 5x minus, instead of a y, since I know y equals 5x plus 8, I'll plug in 5x plus 8 for y. Equals negative 8. So let me take care of the parentheses, so I'll distribute this negative sign. Same thing as multiplying by negative 1. So I have 5x minus 5x minus 8 equals negative 8. So when I simplify, 5x minus 5x, those cancel. So I'm left with negative 8 equals negative 8. So as you can see here, I have no variables left. My main goal was to solve for x, solve for y, so solve for a variable, and all my variables canceled out. So what we need to do, we need to examine this. So we have negative 8 equals negative 8. So first off, does that make sense? In this case, yeah, it does make sense, because negative 8 does equal negative 8. So this is true. And whenever we get down to something like this where we run out of variables, our variables eliminate, and what we have remaining is true, we say our solution will be all real numbers. And this means no matter what ordered pair we plug in to the top equation and bottom equation, they will both be satisfied. Okay? These lines are actually the same exact line. They overlap one another. All right, pause the video if you need more time. Okay, next problem. Similar to the last one, we have a variable that's all by itself, so we will take this negative 2x plus 9, and since we know that this equals y, we will plug it in for y in the second equation. So when we do that, we get 5x minus 4, instead of y, we have negative 2x plus 9, and then equals negative 10. So only difference here, again, I'll keep reiterating it in this video, we are just replacing this variable y, since we solved for it, with the expression it is equal to. So we can distribute our negative 4. When we do that, we get 5x plus 8x minus 36 equals negative 10. So now I'll combine like terms. So 5x plus 8x is going to be 13x. And I haven't touched this minus 36. And I haven't touched the negative 10. So now I'll solve for x. I'll add 36 to both sides. And when I do that, negative 36 plus 36 cancels. So I get 13x equals negative 10 plus 36, which is 26. So to get the x by itself, I'll divide both sides by 13. When I do that, 13 divided by 13 cancels, so I get x equals 26 divided by 13, which I know is 2. And since I know that x equals 2, I can take that 2 and plug it in for x in either the top equation or the bottom equation. It does not matter which one you pick, you should get the same answer for both. So I'll plug it into the top, so I get y equals negative 2 times 2 plus 9. So just replace this x with this 2. So when I evaluate this, I get y equals negative 4 plus 9. And negative 4 plus 9, last time I checked, is going to be positive 5. So I've solved for x, I've solved for y, so I know these two lines, when graphed, cross at the point 2, 5. Remember, x always goes before y. Order is very important here. Pause the video if you need more time. Next one, a little bit different here. Okay, a little more work for us, a little tougher. So if we take a look, we have x plus 8y equals 15 and 7x plus 6y equals 5. So right off the bat, we can notice that we don't have any one variable that is solved for currently. Up top here, we've got x and y on the same side. Down bottom, we've got x and y on the same side. So first off, we need to solve for a variable. So to make life easy on us, let's take a look and see if any of our variables have a coefficient of 1 or a negative 1. If they have a coefficient of 1 or negative 1, that means we most likely will not have to deal with fractions. Okay, so taking a look at this top equation, this x has a coefficient of 1. So let's solve for that x. So I'll rewrite this equation over here. X plus 8y equals 15. And to get the x by itself, I will subtract 8y from both sides. When I do that, 8y minus 8y cancels. So I get x equals negative 8y plus 15. Or if you had 15 minus 8y, that's also okay. Alright, so now that I know that x equals negative 8y plus 15, I will take this negative 8y plus 15 and plug it in for x in my other equation. So when I do that, I get 7 times negative 8y plus 15 plus 6y equals 5. So I'll distribute the 7 to get rid of the parentheses. When I do that, I get negative 56y plus 105 plus 6y equals 5. So I'll combine like terms. Negative 56y plus 6y is going to be negative 50y. And I haven't touched this 105. I haven't touched this 5 either. So I'll subtract 105 from both sides. It'll be the first step in getting the y by itself. When I do that, 105 minus 105 cancels. So I get negative 50y equals 5 minus 105, which is negative 100. So last step to get the y by itself, since negative 50 and y are being multiplied, I'll divide by negative 50 on both sides. Negative 50 divided by negative 50 cancels. So y equals negative 100 divided by negative 50, which is 2. So now I can take that 2 and plug it into either the top equation, the bottom equation, or I have this manipulated equation down here. And by manipulated, I mean I haven't changed it at all. I just kind of switched the order of things around. Okay, I just moved this negative 8y over. So since I'm solving for x and the x is by itself here, how about I make life easy on myself and just plug in 2 for y right here. So I get x equals negative 8 times 2 plus 15. So when I evaluate this, I get x equals negative 16 plus 15. And negative 16 plus 15 is going to be negative 1. So I know these two lines cross at the point negative 1, 2. And again, I don't think I can say it enough. We plugged in this 2 for y into this manipulated equation over here. If you plug it into this original top equation or original bottom equation, you would also get negative 1 for x. All right, I'm moving on. Okay, now we have x plus 2y equals 1 and 2x plus 4y equals negative 2. So very similar to the last problem, I'll examine all my variables and try to find a coefficient of 1 or negative 1. So taking a look at this top x here, that has a coefficient of 1. So I'll rewrite this original equation over here. And I'll solve for x. So to solve for x, I'll subtract 2y from both sides. When I do that, 2y minus 2y cancels. So I get x equals negative 2y plus 1. Or you could write 1 minus 2y. So now that I know that x equals this negative 2y plus 1, I will take negative 2y plus 1 and I'll plug it in for x in my bottom equation. So when I do that, I end up getting 2 times negative 2y plus 1, just replace the x with negative 2y plus 1, plus 4y equals negative 2. So to take care of the parentheses, I will distribute this 2. When I do that, I get negative 4y plus 2. And then I haven't touched this positive 4y or this negative 2 yet. So now I can combine like terms. So when I do that, I've got negative 4y plus 4y. Well, that's just 0, so they cancel. So I'm left with 2 equals negative 2. So my goal here was to solve for a variable, get a variable equals some number, x or y equals a number. So when I went through this process, I didn't do anything wrong, but I got 2 equals negative 2. My variables ended up canceling out. So first off, we need to examine this. So first off, does 2 equal negative 2? No, this is false. And because this is false, that means our solution will be no solutions. And this is because these lines are actually parallel. They have the same slope, so they'll never cross. And because they never cross, we won't have a solution for them. Okay, no matter what ordered pair we plug into the top equation and bottom equation, these will not be satisfied simultaneously. Next problem. So we have 2x minus 6y equals negative 24, and 4x minus 7y equals negative 18. So this one's a little tougher. Both equations are in standard form, and looking at our variables, we don't have a coefficient of 1 or negative 1 in any of these. Okay? So what I'll do next, I'll see if I have one equation where 2 of my numbers are divisible by the third number. So looking at my bottom one, I've got a 4, a negative 7, and a negative 18. So I know when I solve for a variable here, I'm going to be dealing with fractions, which we can do, but I'd like to avoid if I could. So looking at my top equation, I have 2x minus 6y equals negative 24. So looking at this one, 2 is a factor of negative 6 and negative 24. So because of that, I'll try to get this x by itself, because I know when I end up dividing by 2, I won't be dealing with any fractions. So I'll rewrite this equation first off. I'll add 6y to both sides. Negative 6y plus 6y cancels. So I get 2x equals 6y minus 24. So now I'll divide by 2. And remember, we're dividing everything by 2. When we do that, these 2's cancel on the left side, so we're left with x equals 6 divided by 2, which is 3, y, and negative 24 divided by 12, or 2, which is negative 12. So now that I know that x equals 3y minus 12, I will take that 3y minus 12, and I'll plug it in for x in my bottom equation. So when I do that, I'll go over here, I end up getting 4 times 3y minus 12 minus 7y equals negative 18. So I'll distribute to get rid of the parentheses. So I have 12y minus 48 minus 7y equals negative 18. 12y minus 7y is going to be 5y. I haven't touched the negative 48. And I haven't touched the negative 18 yet. So I can add 48 to both sides. When I do that, negative 48 plus 48 cancels. So I get 5y equals negative 18 plus 48, which will be a positive 30. So to get the y by itself, because the 5 and the y are being multiplied, I'll divide both sides by 5. When I do that, 5 divided by 5 cancels. So I get y equals 30 divided by 5, which is 6. So now that I know that y equals 6, I can take that 6 and plug it in for y in the top equation, the bottom equation, or this manipulated equation over here. So I'm going to choose this manipulated equation because it's probably the easiest to deal with in my mind. So I have x equals 3. Instead of y, I have 6 minus 12. 3 times 6 is 18, minus 12, and 18 minus 12 will be 6. So these two lines, when graphed, will cross at the point 6, 6. Okay, pause the video if you need more time. I'm on to the next one. Okay, last problem. Okay, and it looks like it's a little bit tough. So we've got negative 3x minus 4y equals 8, and we have negative 4x plus 3y equals 19. So looking at my variables first, out of my 4 options there, the 2 x's and the 2 y's, I don't have a variable that has a coefficient of 1 or negative 1. And on top of that, looking at my top equation, I've got negative 3, negative 4, and 8. And at my bottom equation, I've got negative 4, 3, and 19. So because I don't have one number that is a factor of the other two, I'll be dealing with fractions. So at this point, we really just got to pick a variable that we want to solve for. So how about we pick this y right here? We'll solve for that. So if we do that, I'm just going to rewrite this equation. We solve for this y, we can add 4x to both sides. Again, it does not matter which variable you choose. You will get the same answer, or should get the same answer. So negative 4x plus 4x cancels, so we get 3y equals 4x plus 19. We'll divide both sides by 3. Dividing everything. When we do that, those 3's cancel, so we get y equals 4 over 3x plus 19 over 3. So now that we solve for y in the bottom equation, we'll take this 4 thirds x plus 19 thirds, and we will plug it in for y in the top equation. So when we do that, we get negative 3x minus 4. And instead of y, we've got 4 over 3x plus 19 over 3 equals 8. So the process doesn't change, we're just dealing with fractions now. So we'll distribute this negative 4 to both sides. So we get negative 3x minus 16 over 3x minus 76 over 3 equals 8. Okay, so we'll combine like terms, and when I'm combining like terms, I'm going to have to do a little bit of mental math. So I'm going to write this down in a different color. So we've got negative 3 over 1 minus 16 over 3. So we're subtracting fractions now, so we need a common denominator. So taking a look, I've got a 1 and I've got a 3, so my common denominator will be 3. So I will multiply the top by 3 and the bottom by 3. So I'm just scaling this. So when I do that, I get negative 9 over 3 minus 16 over 3. Okay, and negative 9 minus 16 is going to be negative 25, and my denominator stays the same. Okay, so if I change this back, I have negative 25 over 3x minus 76 over 3 equals 8. Okay, so I will add 76 over 3 to both sides. And when I do that, negative 76 over 3 plus 76 over 3 cancels. So I'm left with negative 25 over 3x equals 8 plus 76 over 3. So I'll do the same thing. Need to do some mental math. I'll do it right over here. So we have 8 over 1 plus 76 over 3. So we're adding fractions, so I need a common denominator. So my common denominator, taking a look here, I've got a 1 and I've got a 3, so my common denominator will be 3. So I will multiply the top and bottom by 3 on the left side. So when we do that, we end up getting 24 over 3 plus 76 over 3. Okay, our denominator will stay the same, and we've got 24 plus 76, which will be an even 100. So I can replace this right side over here with 100 over 3. To get the x by itself, I will divide both sides by negative 25 over 3. When I do that, these cancel, so I get x equals, I'll go back over here to do a little more mental math. I've got 100 over 3 divided by negative 25 over 3. So I know when I divide fractions, I need to flip whatever's being divided. Okay, so this negative 25 over 3 is splitting up this 100 over 3, so I will flip that and change my sign to multiplication. So I get 100 over 3 times 3 over negative 25. So if I'm changing colors again, if I can simplify some of these, I've got 3 and 3, so that'll become 1 and 1. I've got negative 25 and 100, so this will become 4, and this will become negative 1. So that leaves me with 4 divided by negative 1, which is going to be negative 4. So going way back down here again, I get x equals negative 4. So now that I know that x equals negative 4, I can take that negative 4 and plug it in for x in either the top equation, the bottom equation, or this manipulated equation. Okay, so how about we plug it into the manipulated equation again? We'll continue on that trend. So we have y equals 4 over 3. Instead of x, we've got negative 4 plus 19 over 3. So 4 over 3 times negative 4 is going to be negative 16 over 3. And then we're still adding 19 over 3. And negative 16 plus 19 is going to be a positive 3. Our denominator stays the same. will still be 3. And 3 divided by 3 is 1. So we get y equals 1. So we know these two lines cross at the point -4, 1. So that concludes this example video. At this time, I recommend you moving on to the practice for substitution.